Hello, and welcome to the Equations to Graphs, Sine and Cosine Parent Functions video. Wow, that got really long and specific. I was going to do just one video for tonight's homework. However, I was doing so much, I thought I might break it up into two. So for right now, we're just going to be focusing on the parent functions and the features of cosine and sine. So first, let's look at those features of trig functions. So let's see, we'll write that up here. Ooh, I don't know what just happened. I figured out how to get graph paper on here, but I don't know why it's so dark. Hopefully in the next one I'll be able to figure that out. Okay, so features of trig functions. So there's going to be a few features we talk about. We're going to be talking about domain and range. Okay, that's never going to stop. We're going to start talking about something called a period for a trig function. We're going to talk about x-intercepts, and then we will also be talking about amplitude and asymptotes. Asymptotes we've already talked about before, but this is not going to be for every trig function, so this is only going to be if applicable. So, for instance, today, asymptotes, our functions aren't going to have asymptotes, but they will have amplitudes. Like I said, we'll talk about that. But there are two words here we haven't really used before, which are period and amplitude. Or sorry, amplitude. So for our period is the number of radians required to show one quote-unquote cycle of the repeating pattern of the graph. So when we're talking about period, both our sine and our cosine graphs come from the unit circle, and after you go around the circle once, it kind of starts to repeat itself. So that's about what we mean by one cycle or one period. Just when does that start to come up again? When do we start to get coterminal angles? The other word I was talking about was amplitude. So the amplitude is the height, or you can think of that as distance from the midline. And the midline is just a line that goes through the middle of the graph. And amplitude, as I said, it's only applicable in certain functions. So amplitude is for sine and cosine only. It's for sine and cosine only. So let's go through, let's get to graphing our functions and finding some of those features. So first, we are going to be talking about cosine. So when we graph cosine, we'll say that f of theta, or of our angle, is equal to cosine of theta. Now, if you remember cosine of theta from our unit circle, cosine was all of our x values. So we have to be thinking about the x values on our unit circle. I am going to take a moment. I'm going to pause the recording, draw the graph, and start recording again. So feel free to pause after that moment so you can kind of write all that down. So I now have my graph set up along with its features. So as the features, again, we're looking at domain, range, period, amplitude, asymptote, and x-intercept. I've put this down here because we are going to create a parent table along with the parent graph. And then over here, you can see that I have 1 to -1 on my y-axis, and on my x-axis, I have every tab or every marking at pi over 4, but I've only written it at every pi over 2, or half a pi, if you'd like to take a look. So I'm going 2 pi in the positive direction and 2 pi in the negative direction, just so we can see the full piece of the graph. So let's get started. So just a reminder, this comes from our unit circle. All of these pieces right here, all of our radians, those are our angle, or our degrees. So I'm going to ask, hey, from the unit circle, what happens? So on the unit circle, when our degree is 0, or our radian is 0, what's our x value? Oh, well, that is going to be 1. So that'll be right there. How about at pi over 2? What's the x value or cosine at pi over 2? Well, that's going to be 0. How about at pi? I'm going to keep doing this. So at pi, what is our x value? Well, our x value there is going to be -1. At 3 pi over 2, what is the x value on our unit circle? Well, that again is going to be at 0. And then at 2 pi, what is my x value? Well, we've come all the way back around and we have an x value at 1. So what we've really done is we've really just unwoven our unit circle. So here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So there's all of our quadrants of the unit circle just unwoven. And again, notice I didn't draw like alligator teeth. I made sure everything was nice and curvy. And I'm going to put a little arrow at the end over here to show this keeps going on. Now let's try going backwards. Well, if we went backwards, instead of starting with quadrant 1, we'd start with quadrant 4. So what's the x value at negative pi over 2? Well, that's going to be the same as 3 pi over 2. So that's going to be at 0. The x value at negative pi, which coterminally is the same as positive pi, is going to be at -1. The x value at negative 3 pi over 2, which is going to be the same as pi over 2, is going to be at 0. And the x value at -2 pi, which coterminally is the same as 0, is going to be at 1. So we have our quadrant 4, quadrant 3, quadrant 2, and quadrant 1. So we can see how it's curving all the way through, and it's going to keep repeating itself no matter how many times you go through the unit circle. So we can see this is really continuous. So if we want to take a look at our domain, we can say, oh, well, that's just going to be all the things. -infinity to infinity. There's no stopping it. Our range, we're really just going back between -1 and +1 because those are the highest and lowest values on our unit circle. So we're going to use a bracket here for -1 and +1. For our period, again, we're saying how long does it take to repeat itself? So there's a few different ways you can look at this. You can go top to top, or peak to peak. You can go trough to trough or bottom to bottom. I like to go peak to peak. So if we're starting up here at 0, we go all the way down, we come all the way back up, and we start to repeat ourselves right here at 2 pi. So it takes 2 pi radians to start repeating itself, or 1 full circle, which doesn't really surprise me. So our period is 2 pi. Our amplitude, remember our amplitude was the height or the distance from the midline. So for us, the midline, like I said, it's in the middle of our graph. It's going to be a line going right here. In this case, there you go. It's on our x-axis. So this is the midline right here, or where we kind of keep hitting the middle of the graph. And we can see that the distance from our midline down is just 1 unit, or from the midline up, that's just 1 unit. So we have an amplitude or height of 1. We don't have any asymptotes, so we can just say it's not applicable. It's not a thing we have to worry about. But the x-intercepts get very, very interesting. So before I write down the x-intercepts, I want to make the parent table for this graph. So let's see the parent table for this graph. We're going to be using every pi over 2, starting at negative pi over 2, 0. Oh, I did not leave myself enough space, I guess. Pi over 2, and pi. This way that we have a few points in both the negative and positive section. If I take a look at the graph right now, I see that at negative pi, that y value is at -1. Negative pi over 2, it was at 0. At 0, it was at 1. At pi over 2, it was at 0. And at pi, it was at -1. And again, we're also choosing this not only to have angles that are both negative and positive, but also because we have one full period here. So if we can transform this table, then we can go through and just continue that pattern in transforming the graph. Now let's go back to that last feature of the x-intercept. So here's the thing, we don't have just one x-intercept, we have an infinite number of x-intercepts because this graph keeps on going. It's going on and on and on and on forever and ever. So what we're going to do is we're going to pick an x-intercept. I'm going to pick this one right here at pi over 2. So watch what I do. So I'm making my point. Pi over 2. Well, now I have to think, okay, so I've picked one of them, but I need to keep going. So I see that my x-intercepts are always the same distance apart. They are always pi apart. So I'm going to say, well, what if, I took this number, pi over 2, and I added pi. But I don't want to just add pi once. I want to add pi as many times as I want, or an n number of times. Now, I can also subtract them as many times as I want. So what I'm going to do is I'm going to say this n, because you can't just throw in random things. N is going to be an element, that's what the little z is. N is an element of the integers, which is what that fancy z part is. So again, right here, n is an element of the integers. And what that means is that n is any positive or negative number. So we can go pi in the positive direction as many times as we want, or pi in the negative directions as many times as we want. So we've picked one of our x-intercepts, and then we were saying, hey, we want to go pi in either direction, with that n being positive or negative as many times as we want. But remember, this is a point, so I do want you to write comma 0 to say that our y values will be 0. So this is everything you need to know about the parent graph, table, and features for our cosine function. Now let's just do the same thing with sine. So again, I am going to pause my recording, kind of get it all set up. I'm going to be using the same features and scaling for my graph, and then we'll fill it in. So as you can see, I kind of did that down below right here. Okay, so again, using same features, domain, range, period, amplitude, asymptote, and x-intercept. I've set up something for my parent table, which I've made a little bit longer now. And I also am using the same scaling for my graph. The only difference here is instead of asking myself, hey, cosine is my x values on my unit circle, instead of asking those questions about my angles, now we're asking about the y values for my sine function. So taking a look at our different angles or radians, what is our y value on the unit circle? So at 0 radians, what is the y value at that point? Well, that's going to be 0. Oops, there we go. At pi over 2, what is the y value of the coordinate at that point? Oh, well, that's going to be 1. At pi, what is the y value? Well, that's going to be 0. At 3 pi over 2, what's the y value? It's going to be at -1. And at 2 pi, what is the y value? Well, it's going back around to 0, and that's going to be 0. So again, we've taken our unit circle and unraveled it so that we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we've taken our unit circle and unraveled it to show, hey, here's the progression of our y values. And again, you can see I'm curving everything because it's coming from our unit circle. Please, no alligator teeth. I'm also going to put a little arrow here saying, hey, we're going to keep going. So from here, if we went backwards and asking about our negative angles, well, at negative pi over 2, remember the coterminal angle to that is 3 pi over 2, which is at -1. And you may notice as we do that, you may just start repeating the pattern, but backwards. So at negative pi, which is the same as pi, the y value there was 0. at 3 pi over 2, pardon me, at negative 3 pi over 2, which is the same as pi over 2, that y value is 1. And then at negative pi over 2, which is the same as 0, the y value there is 0. So again, we have our quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And so now we have this continuing graph. You may notice it looks a lot like our cosine graph. The only difference is kind of its starting point, which is true. We noticed that when we took a look at our unit circle, all the x and y values kind of repeated themselves in just a different order. Well, that's what's happening here. So you may not be surprised that a lot of the features of sine are going to be similar to cosine. So for instance, the domain, this just keeps going and going and going. So the domain here is from negative infinity to infinity. The range, well, the lowest value is still negative 1, highest value is still positive 1, so that's going to be bracket, negative 1 to positive 1. The period, or how long does it take to repeat itself, again, you can look peak to peak, or highest point to highest point, trough to trough, lowest point to lowest point, or just any point that repeats itself. So if we start here kind of at our y-intercept where the graph is moving up through the x-axis, the next time it's moving up through the x-axis is over here at 2 pi. So again, it takes one period or one cycle of 2 pi to start repeating itself, or one full circle. The midline here, or the middle of our graph, is also going to be the same on our x-axis. So that's our midline, meaning the amplitude, or the distance from the midline up, or from the midline down, is still going to be 1. There's no asymptotes for this graph, so that's just NA. And then for our x-intercept, we're going to set this up the same way that we did our cosine one, except now the x-intercepts are at a different spot. We just pick a different starting point. So our starting point, you can pick 0, you can pick pi, 2 pi, negative pi, any x-intercept. I'm going to start with pi, just because it's positive. So I'm going to start with saying, hey, I'm going to take pi, and I'm going to add however long it takes to get to the next intercept. In this case, pi. So from pi to 2 pi, it's a distance of pi. So I'm going to add pi, but I don't just want to add it once. I want to add it as many times as I want. So I'm going to say pi n, where n is an element of the integers. And remember, integers can be positive or negative. So we're going through as many times as we can, positive or negative. So we have pi, which is our starting point, plus pi n, just the distance across, comma 0, because again, this is an x-intercept. Lastly, let's work on the parent table for sine. So we're going to be using the same x values here. So negative pi over 2, 0, pi over 2, and pi. That way we have one full period of information, and we also have some radians that are both negative and positive. The only difference here is that the y values are different. So if we take a look at negative pi, we have a y, a y value of 0, and negative pi over 2, we have a y value of negative 1. At 0, we have a y value of 0. At pi over 2, we have a y value of 1. And at pi, we have a y value of 0. So you're using the same x values, but different y values for each of your tables. So if you get confused about where you're at, just remember, use your unit circle. Think of your unit circle, because all we're doing is unraveling that. All right? So if you don't remember the y values, use your unit circle. Here are the parent tables for cosine and sine. Feel free to just look them up online. There's tons of pictures on Google. But in the next video, we are actually going to spend some time transforming these and what that may look like.